Welcome back to video lesson 7, part 2. This part's optional unless, of course, you miss class, in which case you should be viewing this. We left off describing the differences between fats and oils, and now we're going to look more specifically at the structure of fats and oils. So, the structure of fat and oils have in common that they are made up of a glycerol backbone plus what's called 3 fatty acid chains. So I'm going to show you the structure of a glycerol backbone, and this is all one molecule. It starts out with a CH2OH, which is attached. I'm going to draw a nice long line so we can line it up with the next part. CHOH, which is then attached to another CH2OH. That is a glycerol backbone. And when we want to build a fatty acid, we add a fatty acid chain to each part of the glycerol. The fatty acid chains are right here. Fatty acid. And they're a long chain of carbons, and at one end they have this COOH group, which equals a carboxylic acid. That's why they're called fatty acids. And when we join these together in a synthesis reaction, in particular the only synthesis reaction we learn in grade 12, a dehydration synthesis, we end up getting fats and oils. So here's how the dehydration synthesis works. Your OH and the H over here come together to produce water, and then the carbon ends up bound to the oxygen that's left behind. So it's going to happen 3 times. So what we get, and I'm going to use colors to try and help you follow this, we get the backbone. I'm just going to move the H2 here over to this side so it's not in the way of the bond forming. That's your glycerol backbone, and it's going to attach to your fatty acids. So the oxygen, and then the carbon, the double bonded oxygen, that's this part here that it's attaching to. Okay. And then we're going to draw in the rest of the carbons, but we're going to be lazy or efficient, as scientists are wont to do. We have 1, 2, 3, 4, 5, 6, 7, 8, 9 carbons. So that's going to be 1 carbon, 2, 3, 4, 5, 6, 7, 8, 9. A carbon, 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 carbon. The peaks just represent carbons. Okay, and if nothing else is attached to those peaks, it's assumed it's bonded to the hydrogen. We're going to do the same thing over here. One, 2, 3, 4, 5, 6, 7, 8, 9 again. And then we're going to do the same thing here, but we have to be careful. Because if we look very carefully, we're going to see there's a little kink in this chain here. And what you'll notice is you have a carbon that's double bonded to another carbon. So we're going to draw 1, 2, 3, 4, 5, 6 carbons that are normal. Then draw a double bond followed by 1, 2, 3 more carbons. So that's 1 carbon, 2 carbon, 3 carbon. That's the quick way of drawing the fatty acid chains instead of drawing out all those carbons and hydrogens. And all together, this is considered a fat, but remember, in the dehydration synthesis, we also produced 3 molecules of water. Okay. And we'll just put a line here and say it's called a fat or an oil. We'll explain how we can tell the difference. Or because it has a glycerol backbone plus 3 fatty acids, it's also referred to as a triglyceride. And sometimes you hear people talk about the triglyceride levels, which get measured when they're looking at their cholesterol levels. Now, I mentioned there the fact that on this one fatty acid, we actually have a double bonded carbon. That's what determines whether or not something is saturated or unsaturated. We have to look at the fatty acid chains. I'm just going to divide this page in half to compare the two. Okay. So on the left, we have an example of a fatty acid which is saturated, and on the right, one which is unsaturated. Now, saturated means all the carbons in the chain are single bonded. They are only sharing a single pair of electrons, are single bonded, and otherwise completely saturated with hydrogen. Anywhere a hydrogen could bond, it is bonded. In contrast, if we look over at the unsaturated chain, some of the carbons are double bonded, meaning they're sharing 2 pairs of electrons, rather than being bonded to hydrogen atoms. Now this makes quite a big difference, especially in our body and to our health. Because if something is saturated, you look at its structure, it has a straight 3D shape. Whereas if it's unsaturated, it has what we call a kinked 3D shape. So if we're to simply represent the fat or oil by representing the glycerol backbone in red, and then the chains, the fatty acid chains, in black, in this case we'd have 1, 2, 3 nice and straight chains. Then the next molecule could come in. If it's nice 3 straight chains. The next molecule could come in with its nice 3 straight chains. And they can pack very tightly. So the molecules can pack together tightly. Whereas when they're unsaturated, I'm just going to draw the glycerol backbone, and the beautiful yet kinked chains interfere with the next molecule coming in too closely. So they can't pack as tight. And if you remember back to some basic chemistry and the states of matter, when things pack more tightly together, they are known as a solid. And when things are packed more loosely, so the molecules cannot pack as tightly, they are more likely to be a liquid. And this is why when we talk about fats, they tend to be saturated. And when we talk about oils, they tend to be unsaturated. Okay, I'm just going to stop this video there. It's a good spot to stop. And if you need to continue watching because you've missed the class, I'll see you or be talking to you in a second when you start watching video part 3.